Hello, my students. Well, we're going to start by creating some interfaces. In the past, what we have been doing at school is that we have been using interfaces that I have given you. But because of the nature of ICS 211, it is important that you learn to create interfaces because that way you will learn to use them better. Okay? So let's start by reviewing what an abstract class is. To begin with, an abstract class will always have the keyword abstract, as you can see in here. It will always be in the heading, and an abstract class can never be instantiated. And another thing is that within the abstract class, you may declare abstract methods. Okay? An example of this is the homework that you're currently working in, the one that has the abstract interface math operators. Okay? So that is part of something that is abstract, is something that is there and that it cannot be instantiated, meaning that I cannot create objects of math operators. For example, in this class that I'm showing over here, there is no way that I can make a class math operators. Now the interface, well, what a surprise, it uses the keyword interface. And the interface does not run. It will not run because it doesn't have code. It only shows what are the inputs and outputs of each one of the methods or parts of the headers, of the headers that we're going to be showing. Now, in an interface, the interface just doesn't run, but it has all the headers, and some other class is going to be implementing that interface elsewhere. That is sort of what you're doing right now. You're actually implementing an interface, that it's for math operators. So here is the class that I actually gave you to do the homework with, right? So we have the abstract interface math operators, and then we have each one of the methods, 1, 2, 3 methods that you're going to be implementing, right? That whenever you have your other class, you're going to be implementing the interface math operators. And in here, look at that. It says abstract double add, and then I have 2 arguments, double number 1 and double number 2. And look at this. Here is the important part, how comments actually make sense. Okay, now in this case, comments are our guide to know what's going to be done within this method. Look at this. This method will receive 2 double numbers as parameters, there they are, and it will add them and return the result. So in this instruction in here, it's telling us what the method is going to do. Now it's going to return the result how? As a double, because it's telling you that it's a double method, which takes two double numbers. Now in here, we say that this method will receive a double number, there it is, as a parameter, and then it's going to calculate its absolute value and then return it. So it's a double number here, and it's going to return the absolute value of that number. It's also abstract, okay? The next one is a number. It's going to receive an integer number as a parameter, and it's going to check if it's even or not. So now this is an interface. So now we're going to begin creating our interfaces. So remember when we talk in class and I told you, well, think of an interface. The interface is as a physical interface is standardized, remember? Because, for example, if we have a plugger, then we can actually use, like an outlet. We can use our power cord to connect in any outlet in the house. It doesn't really matter where the outlet is, and it doesn't really matter what kind of appliance we buy. We will always be able to plug it in, at least in the United States, because that's a standard, right? Now, when you create an interface, you need to know what is needed. For example, in our outlet, what we need is, the power and the grounding and all these things. So we know what we need, right? And then the outlet was created. Now, in our case, we need to know what is needed within the class that we're creating, and then we're going to be able to specify it. Basically, what I have been doing with you in 111, for example, has been to create interfaces or to tell you what you need to do. Nowadays, you're going to be doing the same thing. You're going to be telling me what needs to be done, like in an interface, okay? So let's start by reviewing what we have done. First of all, ICS 211 is all about collections. So it is important that we take into consideration that we will always have more than one object, more than one item to work with. Our objects are going to be collections, a bunch of objects stored in a particular way. The whole idea about 211 is how are we going to be storing that, right? So we will begin with arrays. We actually began with arrays where it had certain laws and certain ways of adding elements to the arrays, and we knew the methods to add, delete, to see stuff within the array. We learned also about array lists, and lately, in 211, we have learned about linked lists. We did a little bit of coding. All of them are collections. That's what they have in common. So, if we talk about the linked list, what do we need a linked list to do? Now, in this class, I am going to talk a little bit about everything that we have covered so far in 211. First, to remind you everything, and to get your brain out of exile, because I was not there for a whole week, right? And I don't want your brain to rot and be bored, okay? So, what do we need a linked list to do? We tried first, a linked list, a regular linked list, and we did several versions of those things. So the first thing that we need to do is, whatever it is that we need to do with the linked list, we have to describe how the list is going to look, how it's going to behave, and how it's going to work. So we're going to describe the list and its functionality. Okay, and remember, the linked list is a collection, and with that said, that means that it's just another way of group a bunch of objects of the same kind and deal with them in a specific way. Oops. Okay, so in here, if I add an element to the linked list, the question that arises is where? Where am I going to add the element? At the beginning, at the end, at the top, at the bottom, to the right, to the left, in the middle? Okay? If I am going to remove an element from the linked list, how am I going to be removing that element? Am I going to remove the first one? Am I going to remove the last one? If not, which one? The one in the center, in the middle, to the left, the second, the third, the one that contains an X? Which one am I going to be removing? Now, aside from that, about adding and deleting, we have an iterator. An iterator in ICS 211 will be the process of visiting each element. And remember, somebody in class I was like, oh yeah, we can iterate. And somebody said, well, what is that? Actually, that was Mitch that asked what was the iterator. And the iterator is the process of visiting each single element. So I'm going to go check one element and see what's inside. Visiting means going there and seeing what is inside each one of the nodes. Then I go to the next node and I visit, I see what is inside. I open it, I see it, I don't do anything, I don't delete it, I don't move it, I just visit it. Okay? Now, we need to know what kind of iterator do we want for our collection. Okay? For example, am I going to start by printing or visiting the first added element first? I just put print, but in reality it's visiting. Am I going to be visiting the first added element first? Or am I going to print or visit? Am I going to visit the last added element first? Which side of the list am I going to start with, And what am I going to be doing first? So that's the question. So let's take a look at how our linked list looks like. Now, notice that because of the graphics and the way that a PowerPoint is, whenever my arrow is empty in here, it has just like a greater than symbol, and it's pointing to the bottom, that means that it's pointing to null. Okay? So to begin this, my linked list has only one element, okay? And last and first are both pointing at the same element as soon as I have that. And that will be the beginning of my list. Once I have this, then I can go ahead and add another element. The very moment that I add another element, then first remains here because that was the first one that I actually entered, that I actually created. And then I linked last. Notice that this arrow is filled in the middle. That means that it's not null. This one is pointing to null. And anything, as I said, that is touching ground, that it's going down, that is null. Okay, so there you go. Now I have two elements. What about adding just another element? So as I am adding a new element, I am moving last, I am moving last to the left, and I am adding the element. Now notice that for me, in order to go from here to here, it is okay because list has a reference. This one has a reference to it. Now, when I add another one, I am going to need a reference to this. That way, while I create the new node, actually, when I create the new node, I can point it to last and then move last over here. After that, I can create yet another one, okay? Now, the beginning of the list is right here. That was the very first one that I node that I actually added, okay? So now, from here, we have our linked list. Now we need to start working with it. So, if I add the element, where do I add the element? Now, we saw that within the list, as you saw that I was moving around, you saw that I was adding the element after the previous element or after the first element. Therefore, if I wanted to add yet another element, it will be right here, right here, and it will be pointing to the last element in the issue, right? So where am I adding the element? I am adding the element after the previous element. I could be adding them the other way, but that will have a different dynamic. And if I say that I'm going to add it after, then when I am specifying my interface, I have to say that the element must be added after, because I am the boss and I am the one that is defining the interface. And remember what I tell you, this is America, you can do whatever you want and ask people to do whatever you want. Therefore, we're going to say that it's going to be added after the previous elements. Then we move on and we say, well, let's remove an element. Okay, which element am I going to be removing? Am I going to be removing the first element? The first element is here, remember? And in order for me to remove the first element, I can do it, but I will need a traversal. And every time I do one traversal, right, is O of n, because I am moving, I am traversing once where n is the size of my list, right? So yeah, I will need a traversal. If I remove the last one, which is this one, it will be easy. I just move last to the next node. So meaning that I am going to move this last right here and it's gone, right? Like that. Once I do that, the other element, this one over here, is going to disappear because there's no reference to it. Bye-bye. Okay? Now, if it's not that, it's not the first, and it's not the last, then which element am I going to be getting rid of? Okay, so I have several options. I can look for a particular element within my list. For that, I must traverse and visit every node. So I'm going to go through the list and visit every node and checking, what is in there. And remember what we say? We must keep a cursor and a precursor. Okay, so that's much for removing the element. Right now, I'm going to pause right here and we'll continue on video 2.